If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to lecture 4 of this grid protection series. So today I have taken again 5 questions. Question number 16, 17, 18, 19 and 20. Okay, then let's try to solve this. What is given in 16? Consider the protection system shown in figure. Circuit breaker 1 to 7 is given. Ground fault is occurred here at the impedance, and circuit breaker 4 is stuck to operate. It doesn't operate. Suppose somehow it has maloperated, it is not working properly. The relays are the valid sequence of circuit breaker operation. Which circuit should be tripped first? Okay, now what do you think, if there is a fault, which circuit breaker should come first? This is a fault, this 4 should trip first, because I want to isolate this line. You want to take out this line. For taking out this line, you should take 4, 5, 6, 7, all these should go first, then this will come. Okay, so if 4 is not working, then these will come. Okay, so the first thing you at the very beginning, so it will wait for some time so that 4 trips. If it doesn't trip, then it will come. So at the first instant it will try to trip 4. 4 is not tripping, that is a different thing, but at the first instant it will trip all 4. If it is not tripped, after some time it will go to this. So at the very beginning, which will trip? Obviously 5, 6, 7, these will trip. 5, 6, 7, these will trip. And once 4 is not tripping, that's why it is going to 3. And then 3 alone will not serve the purpose, because current can come from this side also. So that's why 1 can trip. Current can come from this side also. So that's why 2 trip. So all other sequence is negative. This one will not work, because 1 is not in the first instant. First instant this 4 should trip, because fault is here. So these 2 are already gone. Again 5, after 5 it should not go to 1. 5 it should 5, 6, 7 should operate simultaneously. So it should come together. So you can see here. So that's why obviously option C is the correct answer. The voltage phasors of 2 terminals of a transmission line length of 70 km have a magnitude of 1 per unit, but they are 180 degree out of phase, assuming that the minimum load current is 1/5 of the minimum 3-phase fault current. So minimum fault current is 5 times the load current. So if you draw it, if my this angle, this is at 180, this is at 180. 180 is nothing but -1. You know this one. 180, 1 is here, then 1 angle minus 180 is there. That means minus angle. Okay, let it be. So suppose this is ZL and this impedance. So in normal condition, what is the current flowing? 1 minus -1 by ZL angle theta. So it will be 2 by ZL angle some minus theta. So what is your minimum fault current? Minimum fault current is 5 times of that one. That is 10 by ZL, 5 into this. So this is the minimum fault current. Now suppose the first one, the distance let us read the option question first. They have asked you which will not trip, which type of protection scheme will fail here. So if you see the first one, it is a Moho relay with 80% setting, directional overcurrent relay, which will set to 1.25 times the maximum load current. From the option itself you can get an idea. So from the second option, if you see directional, the first option will coming. Second option you can see it is directional overcurrent 1.25 the maximum load current. So your fault current is 5 times the load current. You can see load current is 1/5 of fault current. That means fault current is 5 times. So because you are giving setting 1.25, so obviously relay will trip, because your fault current is 5 times of your normal load current, but you are giving setting 1.25 or no maximum load current. So anything above 1.25 times it will trip. So your fault current is 5 times, so it will trip. So obviously B will trip. So there is no question of B is not tripping. See, pilot relaying system with directional comparison scheme. Pilot relaying system is a segregated phase comparison scheme. Both these are concept of that distance protection, where you have seen 80% first step, then 20% is left. So there is a gap, there is a delay between operation. To speed up this, so from both sides directional elements are connected, so that the operation becomes speed up, and that 20% can be taken care of. So this D is the little extension of C only. So this will take care of both, by 80% and 20%. So these two will not be the answer. So obviously we are left with option A. So option A will be the answer, but we can check it also a little calculation, because it is 80%. So 20% is left out. So you can think that anything in occurring in 20% it will not trip. So here you can think it in this way with some approximation. Suppose 2 generators, these are fixed. Suppose somehow the terminal voltage are fixed, because they are connected to generator output terminals. Suppose you are giving settings here 0.8, 80% of line impedance, that means 0.8 of ZL. So if there is a fault here, current will flow from here also, current will flow from there also. So if my relay is connected here, let us assume, and this is IF2, and this current is, total current is IF. So what is my IF1? 1, and if the fault is here, then it will be 0. If voltage is here, 0. So it will be, because it is, let me assume it is dead short. They have not given. Okay, let me assume it dead short. For simplicity, just we are assuming it can be any voltage. So 1 angle at an angle 0 divided by ZL, 0.8 ZL. So 1 divided by 0.8 ZL, it is 1.25 of ZL angle theta. And your IF2 will be, current will come from this side, so that's why minus is already there, because initially current was flowing like this. Now this current will be negative, so you can see it is already negative. So if it is 0.8, this will be 0.2, so 0.2 of ZL theta. So it will be 5 by ZL angle minus theta. If you add these two, so your fault current is 6.25 ZL angle minus theta. But your minimum fault current is 10 by ZL, you can see. So this is not the so they are not talking about fault at here. So when the fault current will increase, if you go here little bit more beyond 80%, then you see this side your IF2 will be very increased. Suppose it is at 0.9. So what will be this one will be 1 by 0.9. 1 by 0.9 will be 1.11. Suppose I have given at 0.9 of this setting. So what will be your IF1? IF1 will be 1 divided by 0.9. That will be 1.11 ZL angle, that is whatever, divided by whatever that is. And IF2 will be 1 angle divided by 0.1, that is 10 times. So you can see now if we add these two, it will be 10.11, 11.11. So that means they are talking about something fault over here. If the condition is, lots of assumption I have taken, 2 generators and no fault impedance. So if the situation is like that, that means they are talking about faults near here. So here it will not trip, because you have given up to setting up to 80% only. So it will trip any fault below this level. So that's why A is not the correct option. That means A is the correct option. That is, A will not trip. They have asked you which one will not trip. So obviously A will not trip. From the options, by seeing options also, you can have a guess which one will be the answer. In 18 it is given two machines of power system as shown in below. Transmission line XY has a positive sequence impedance of Z1 and zero sequence Z0. A phase ground to fault with a zero fault impedance occurred. Bus voltage X and bus voltage is given VA, and bus current voltage is given VA. This is 18, and current is given IA, bus and ampere. Then the impedance measured by the ground relay at the terminal. So you have already seen, I have already shown what is Z seen by a distance relay. I have given a formula in that theory. I will give you a link, where it was VA divided by its ratio, PT ratio, and IA divided by CT ratio. If they are not saying anything about CT PT, so let us forget it. So the Z seen is obviously VA by IA. So let us assume that VA IA itself the current they are sensing, and that means after dividing PT. So this is the impedance actually what is measured or what is seen by this. And Z0 will not come into the picture, because for distance relay we are nothing to do with Z0. We can think of Z1, but Z1 we have given settings of this one. For setting we have given Z1. Measuring is always this one. It will always measure this, and it will check whether it is less than that or not. If it is less than the setting, then it will trip. So by giving the setting is given by using positive sequence impedance, that is Z1 or ZL, which is nothing but Z1 is for transmission line, it is ZL. So this is the setting we give, not the seen by the relay. Relay will always measure VA by IA. So don't get confused with Z1 by 2. It is at half, it should be Z1 by 2. It may be equal to Z1 by 2. The relay will measure it. It can, if there is no, it may equal to this one, but this is not the thing that is measuring. Measuring is VA by IA. If it falls below your Z1, whatever setting we have given, then this will trip. It may or may not be equal to Z1 by 2. Question number 19. Match the following list 1 items with the list 2. Types of distance relay preferred, and okay. In what type of short line, medium line, what type of. Now this relay, you can think of on two different concepts. One concept is you will be very familiar with, that is arcing, that is arc resistance fault, arc faults or arc flashing over the discs, which is a mostly resistive type fault. which is very common in my transmission line. So they say it is arc fault, any flashover around the discs, around the insulators. So these are faults of resistive faults. Now this resistance fault, it is this effect is very negligible on reactance fault in reactance relay, and it is very effective in Moore relay, and it is in between, somewhere in between for impedance relay. You can see from the drawing also, I will see. So this is less severe, this is less affected, but least, this is least affected by resistive fault, and this is most affected by resistive fault, and obviously the middle one will be the middle resistive fault. You can see from the drawing also, this is the reactance fault. I have already explained. If you add impedance, then this will moving in this direction, so your X remains same, so your reactance fault doesn't get affected at all by your resistive faults. If you see the Moore relay is something of this fashion. So if your fault characteristics is this, if you are going this, that means you are going outside, you are getting outside its strip zone. You can see you are losing everything almost. So this portion you are losing, you are measuring up to this much, now you are out of this much. If you go little bit, it will be out of its strip circuit. For impedance relay, it is somewhere in this. So if it is this, then also you are losing, but it is in bit, not like that your Moore relay. So as on basis of this only you can segregate this. I am not going. Second one is depend on power swing. So power swing, let us forget it, because power swing is I have not discussed in the theory of that switchgear also. So let us think of this way also, that also you can think. So where you will use reactance relay, where your arc resistive fault is very dominant, where it is very prominent, it will give very effect. Here you will use reactance fault. In that case there will be no effect at all, because whatever the effect of arc resistance will come, reactance will not get affected. So which line is this one? This is, you can think of short line. Why it is short line? Because your short line, your R is less, because it is small length. So the arc resistance will have much impact on R, because his R is length, because of arc resistance. We are getting it now. Suppose it is 5 ohm and your arc resistance is 10 ohm. So if it is a long line, it will be 500 ohm, it will be 50 ohm. So if you add 10 ohm with 5 ohm, the effect is much more. If you add 10 ohm with 500, the effect is less. If you add 10 with 50, then effect is in between somewhere. So here if you are adding 10, then it will give you much more effect. So here you have to use a relay which doesn't get affected by at all. So that's why reactance relay is for short. So Moore relay, it is because it is least it is most affected by the fault. So you will have a line where the effect is very less. That means your long line. In long line, your impedance will be very high. So if you add little bit of arc resistance, this movement will not be very significant. It will move from here to here also only. So it will be within that trip zone only. So you will use Moore relay. Now we are getting it. So it will be in medium relay, medium length impedance relay, where the effect is somewhere in between. Not so extreme, not so low also, not so high also. So you can see here, that's why the option will be, so short line, it will be, you have seen short line, it will be reactance. So A will be with your 2, and then B will be your impedance, that is ohm relay. The inside one is resistance relay. No, I am saying impedance because all are impedance. This is also impedance. These are generic impedance relay. So this is reactance, this is resistive relay, or that is ohm relay, and this is Moore relay. So for medium it will be ohm relay, and then for long line it will be your Moore relay. Consider the stator winding of an internal high resistance ground fault. The current under the fault condition are as shown in the figure. The winding is protected differential protection for 400 by Phi current through the operating coil. What is the current through the operating coil? So it is a standard differential protection question. I1 minus I2, we know from here. What is the difference between this current and this current that goes through this? So it is nothing but I1 minus I2. Now what is I1? I1 is 220 by this ratio. This ratio is 400 by 5, that is 80. Or let me write it this one. Angle 0 means I am not writing. 220 plus J0 minus here also 250 plus J0. If there is J something, you have to write that one, and then you have to take vector difference. But because both are J0, that's why I am not writing here. So it will be, so it is 0.375. minus is coming, it will be I2 minus I1 or I1 minus I2. Oh, obviously it will be I2 minus I1 because current is coming from this side then going. So you will this current minus this current. So obviously it is 375. That is your option C. Okay, then that's all for today. If you like the video, then press the like button and please give your valuable comments in the comment section.